Thanks, Brian. Thanks, Dan. Dan, quick time check. I think you reserved 2 hours, but I want to make sure.
Yes, we did. Yeah, so yeah, we're good on that. Yeah.
And we have Manish Parashar on the line as well. Manish and I actually are presenting together, although I'm the speaking person. So National Data Platform is a platform to improve usability of existing data technologies. We can get that. We can think, if you think of it this way, and think of how working with data can be frustrating, right? Often we have data in repositories, and when we use it, we have bookmarks and notes. Data from facilities, we might have links to limited data services offered by facilities, but if you want to do anything more than that, it gets a little challenging to deploy and build these services. You might have personal files, sometimes zip files in many drives and email our colleagues share with us. We have data and extract, transform, load type of repositories with unresolved dependencies to those. So views over data in general, and many other things. I can list probably 10 more here. And how it works typically for a researcher in our observation is they self-manage their data workflow. They create a lot of data exports. Sometimes they get get scripts or extracts, and try to integrate from that into their own workflows. And all of this gets integrated in a scientific workflow that can then be launched on compute of different sorts. And when they want to collaborate with anybody, they create a often hard to replicate repository to send data to collaborators, or all the files and workflows to collaborators. And the compute products, managing and sharing data becomes a secondary thought, or external activity to whatever they did. So both using data and computing on it and managing and sharing the products of it can be really frustrating. And especially if you try to use it in educational or data challenge context, then using research computing for those things adds extra challenges. So these are the things that, as a team, first of all, we recognize ourselves in experience with working with our colleagues, but also we heard from others. And why is it so challenging to use? There's fragmented access to data, model services, they're all over the place, which is actually good distribution. And there are complexity of formats, interoperability issues, context of use is a big deal that is often not associated to those services properly. And this disconnect between where we are producing and sharing data actually can lead to both contextual and time challenges in how data is being shared with others in terms of usability, timeliness, interpretability of it, metadata. And service deployment practices on top of the data, they are really hard to customize. There's no standard best practices on that. And often when we use data, because of the scale of things, we need scalable or specialized compute. It's compute-ready data, AI-ready data. These are the things we are talking about, but there's no one platform that turns it into a user experience in the research space. In the cloud providers, we have these platforms, right? Amazon Bedrock, for instance, is an example. And then disconnect between this research and education capacity. Can we have our research-grade data sets and share it with our students in our classrooms, or large sums of data? Can we actually turn those into challenges for teaching AI and science to students and informal learners? And then we also lack user experiences to enable team collaboration. And often now in AI-driven, AI-integrated workflows, we have many people working together from different backgrounds, and having them all access to a usability layer or a collaboration enabling platform that links many things together was a gap in our cyber infrastructure space. So instead of building a facility that focuses on one silo, we thought, is there a better way to tackle these usability issues and maybe start integrating and bringing these frustrations and needs in one platform. It's very ambitious that way to challenge these challenges around using and sharing data. But this is, in a way, an ecosystem approach where we are thinking of broad, federated, and extensible. These are our words. Can we promote collaboration, first of all? Can we increase innovation? That's through that collaboration. And while we do that, can we make it easier to customize use of existing and future capabilities in the infrastructure space, from hardware and software to networks and expertise? Expertise sharing is a big part of this. And how we got around to doing this is a centralized portal that brings these experiences together and brings a workspace-driven collaborative studio approach to sharing using data. And then also extensibility through composable endpoints. So these could be service deployments, this could be compute endpoints, and this definitely can be a full-on NDP-like shell for a community that could be integrated selectively into the centralized hub. So what's the flow of capability then we are after here is one can discover data, find services, or integrate models from other catalogs or repositories in one platform. These can be cataloged by roles that have special sharing responsibilities and stewardship. And one can also deploy endpoints that are near data or other specialized facilities. And when you go about using them, you collect them in workspaces to begin individual analysis. And then those workspaces are launchable on various compute platforms, and including some data delivery backends like OSDF that we just heard. And some holes here still, right? I left them really purposefully. Then we can share these workspaces with collaborators in project, classroom, and data challenge settings. They could be students, they could be research colleagues, they could be informal learners that we are trying to make reproducible, teach tutorials through. And also we can expand storage platforms to export final data products, while we give the ability to catalog those data products when the data producer chooses to do so. So providing a general workflow and or process of working, the small capital workflow there, small letter workflow and data management flow in the environment in a way that brings some best practices together. So how do we help with these? Facilitation of data cataloging and integrating platforms to help us use data at scale while bringing some interoperability and usage of data coming from various sources in one platform. The second thing I'm going to talk about today is collaborative workspaces and customizable services that can be deployed, and integration with national cyber infrastructure and cloud resources, and enabling integration of AI into these workflows that can be then turned into services that can enable external platforms like shells, we call them. And on top of that, while we do this research activities, taking some of these research grade efforts and using them in classrooms or data challenges that students can benefit from, and in ways students can have access to large volumes of data and interoperable, highly variable data sets, so they can learn to work with data in a way that's sort of mimics at least real life, but often in real life settings. And we know, well, when we set out to do that, there are lots of known challenges, but also working with the community through these needs assessment workshops and application co-design, and the community includes you. We also would like to understand what we don't know, what the needs are, and build these user experiences around those needs. And can we, while we do that, again, enable user capacity building through educational and training interfaces. Lots of user personas here. Some of them worth mentioning are researchers, researcher educators, data providers or stewards, student learners, research software engineers. So it's a platform approach that enables customization at different levels, from building endpoint services and deploying them for different users, to bringing new data through stewardship, to customization of classrooms and challenges, to customization of full-blown interfaces for different communities under NDP shells. And how does NDP do it? Then there's this main concept of the catalog. This is not a data catalog only. It's a place to catalog data, models, services, workflows, educational materials, you name it, basically. Anything in NDP we'd like to make searchable and discoverable. And some of them might not be open. There could be things that are not open but discoverable with some management and governance practices through authentication, authorization through endpoints. And at least access discoverability is open in that context. And these services can be expanded through this endpoint concept. So, for instance, a data point of presence as an endpoint is when you have data that you'd like to deploy near data services for. They could be extended through the standard core NDP stack that provides authentication, authorization, and some things that integrate this endpoint to NDP and enables that federation. You can also then have that service and discover that as data that enables a very specialized way of working with the data on top of the data itself. So instead of working with data, you work with services through that to work with the data. And then all these can be then collected in workspaces. And those workspaces in collaborative studios can be made available to project, data challenge, or classroom settings. So different personas come in here, different workflows and user experiences come in here, so that we can actually enable reproducible use of those workspace ready to go within a collaborative environment. And on top of that, the loss customization can be, the NDP itself is a shell about all of this. So actually one can come in and brand a new shell for a limited set of data or for a very specialized group of users. So for instance, when there are projects that we all want to leave something behind, that could be achieved through an NDP shell that contributes those data sets to centralized NDP, but brands them as products of that particular project or effort. And the workspaces are launchable on existing compute and data platforms. So there's the ability to expand those. And if you have any needs to expand to what beyond the things that NDP offers today, like the integration with the National Research Platform or Amazon or on-prem clusters, we can definitely talk about those. So those are sort of the customizations and personal workspaces, collaborative studios, as I mentioned, bring your own compute, OSDF Pelican namespace integration, hub shells, right? So, and in addition to deployable near data services and robust ingestion pipelines to the catalog that often NDP gets quoted as. So how can we work with you? Before I go into the details of it, I can say definitely data catalog integration in a way that actually exposes your namespaces on OSDF. If you choose to share the data on OSDF, is a possibility. So it becomes, your data becomes discoverable together with related data sets, and hopefully we can multiply the impact of those data sets. We can provide example AI and scientific workflows from your projects with an NDP for learners or for others who would like to use the services and workflows you provide. As I mentioned, you can create custom shells for your project for large volumes of data or other needs, like, for instance, private data or things that require careful working through services for subsetting and feature detection and other things. We can work on NDP endpoint deployment that makes those services available in the context of the workflows with an NDP. And then we would love to work with you to see if you offer classroom materials or capabilities or create data challenges together. And these are some of the emails. So I mentioned the flow of capabilities. Just to quickly go through these, for discovery, many data sets get registered, and this is something we are continuously improving. This is not going to end anytime soon because this is a process, so to say, that we are learning and working with. You can search data through regular metadata search, and we have some processes to bring in metadata and crosswalk different metadata standards into NDP, so we can make sure data sets can interoperably used and discovered. We have this concept of conceptual search, and including your own ontologies to make data compatible with knowledge graphs so they can be cross-discovered with other platforms. For data that relates to spatio-temporal characteristics, that type of search capabilities are possible. Very recently, like over the last year, NDP, by the way, is still being built. And we have some of these production capabilities, and some of them are in rapid change. We have actually, when you go to NDP, you have some data sets that have a little sign insights next to it. We are bringing in a standard NDP service called democratizing data that actually helps us contextual search based on the usage of the data and insights and who is using the data and things like that, that integrates corpus and other things through foundational models. And all of this actually to serve a future means of engaging with data conversationally. So what do you want? So this is actually ongoing work that we hope to bring onto NDP in the winter timeframe. It's first examples of interacting with all of the data through more conversational interfaces in a like Google Data Commons way, but instead of getting statistics, you get data that you can use. So that's the idea here. So catalog, there's an ingestion process. I'm not going to go through all these movies, but NDP is best shown than talked about because it's a little different than anything I think out there. But we have a data registration sort of process, and that involves also data stewardship on bidirectional data stewardship and crosswalking the metadata standards you work with back to the catalog and things like that is involved in here. And when the data is in an OSDF namespace, for instance, there's this little add data button here that gives us ability to integrate that namespace with the rest of the metadata. And then when you work with NDP workspaces on Jupyter Hub and other interfaces, actually it automatically fetches that OSDF namespace, data from OSDF namespace, like you've seen here, into NDP, into the NDP Jupyter Hub to work on compute environments. Some of the data sets that we use this, for instance, HydroFrame and Hydrogen digital twin for the NAIR pilot. This is a group that had many data sets that are listed here. And we went through a whole approval process. Actually, this waiting for final data steward approval is done. The HydroFrame data sets are on NDP. It's an older slide. So that was published. And actually, Brian and I were discussing bringing the OSDF namespace into this now. And once it's there, you can use it in the context of AI workflows or data challenges, and examples are being generated. Another one is example of Kurt Dutz, whose data is already on OSDF. And I'm giving these quick examples, so there's some ability to go and read and find these. They're in the catalogs, AI workflows that link this data and explain that to different users are published also on NDP. And Education Hub, in this case, is being used to deliver online interactive course content. So that's an ongoing work. But here, it's really large amounts of data from an instrument and simulations coming together in a very interesting use case. This is a time series example on biologging, a postdoc, Jessica Kendall Barr. Jessie actually has multimodal data from a community of researchers, and she becomes sort of the person catalog for this data. So having NDP and cataloging her data and providing her example in an NRP, National Research Platform compatible way, really helped her to design both her collaborative communities and bring it to actually others who could benefit from this data, like governments who care about biodiversity of these animals, and also educational settings again. And the endpoints. These are near data services. What does this mean? We provide a standardized set of services that are core NDP services that can then be used to develop more services on top of those, closer to data, and deployed and brought and federated back into NDP as services. So one can launch endpoints on different platforms, but if, for instance, that's on NDP, on AWS, there's a way to manage those accounts and bring those endpoints in a way that we can make them natively available. So that's another ongoing work that will be deployed and published in September. Why is this useful? Because, for instance, I work with Earthscope streaming data. I can then have an endpoint to develop different streaming and staging services using this. And, some of the historical data I can stage on Pelican, but I can also create services to access the data remotely from NDP and integrate that as a composable service to validate, for instance, something that I'm doing on the earthquake modeling into a larger, more heterogeneous platform or workflow within the central hub. So these near data services also help with things like if the data has egress charges and things like that, you can integrate without moving the data, the products of things that actually products of those services that help in the context of an individual workflow. One of those is Crescent workflow. It's a slope slip analysis that one of my postdocs actually recently ran into, developing an emulator and validating on NRP and validating with Earthscope data. Suddenly we needed Earthscope endpoint to validate something that we were doing on NRP. And this is a general case study for Crescent, for instance, the Cascadia region earthquake site center that works with Earthscope in a very specialized way that way. If you bring multiple data sets from different archives, like in this case, NASA NOAA satellite data, you can definitely bring them together through these endpoints and ensure their interoperability and discover the catalogs through NDP and use the services on top of these catalogs that are, in this case, for instance, in this particular example, deployed on AWX with a specialized service on top of the core stack from Manish and team called CICI. So then there's the rest of it, okay? Collect, collaborate, compute. How does that happen? As I mentioned, you can collect things in a workspace and share in collaborative studios. Something that you can collect, for instance, is Hugging Face model and data integration. If the data is published there, you can bring that into a workspace in NDP. And this was one of the NAIR data sets that was published. That data set is cataloged in NDP. So we actually have tried both automatic ingest from Hugging Face. And then you can add that to your workspace. And I'm gonna sort of quickly went through the workspace creation. That data sets, once added to the workspace and some of the compute components are added to it, that can be deployed on NRP in this case. And one can work with both data and the notebook itself on NRP through that standardized deployment process. One can select compute endpoints. So in this hub, for instance, there is a workspace that has some NDP data sets. And we can have launch options in the NRP Jupyter Hub, or in this case, an endpoint that's deployed in Utah, an on-prem computer. And the NDP workspace opens in that platform. In a way, we can then link that workspace to this compute endpoint. So if the data is on OSDF, for instance, the moment we select the data and add files to current folder, that automatically gets fetched and GitHub or other things can be cloned into this environment. So again, the usability of things that exist and in a way that makes them useful in the context of NDP. OSDF I showed before. Go to Jupyter Hub, that fetching function here again, that can be shown. We are loading a workspace, the collaborative project in this case. I can go and reproduce this together with the person who built this demo. And then once that opens on, these are real-time screen captures. So I'm sort of going over them pretty fast. But the same idea, data is fetched, and then one can then use the data in the context of their analysis. Same concept is now used in classrooms. So instead of the project concept, we can have classrooms and also data challenges. Actually, data challenges are quite interesting because it allows collaborative work of students through these data challenges. And something that we ran over summer, over the spring, Fire Ready Forest data challenge. We only advertised it to students from UCSD because that was our first data challenge in NDP. And the surprising thing was, you can also watch it as I'm talking, there are some like sprints that are workspaces that students go through. And then the main thing, sprint 4, is the challenge question after they learn to work with multiple things. And each student worked with 85 gigabytes of data here, by the way. Of different sorts, right? It's terrestrial LiDAR data, forest inventory analysis, index, fast fuels is a model over many other data sets. So we noticed after we announced this, we were getting these student groups from 8 other colleges and universities. So that was kind of a pleasant surprise that it's self-onboarded to the challenge. Of course, we can limit who can onboard here, but it was an open challenge, and we didn't even have to do anything for the students to find and go through and run the challenge and submit their results. And right now, if you go to NDP onboarding challenge, shows this whole challenge. You can go through it, and there's also the winning challenge entry that was judged through the platform by the judges in a reproducible way. Is also published as the last step, so other students can learn from it. So if you'd like to do things like that, I think there's a paper on this that was in PERC recently. And in Burn Pro 3D, which is a platform my team develops, we actually published the Burn Pro 3D datasets on NDP. And some of those selectively gets made available on OSDF and get cataloged on NDP. So through the Learners portal, we can make our many research collaborators have access to these simulation data sets to develop AIs or other dependent products to these simulations, fire simulations. And we notice over time that our work is a lot of the dynamic data-driven digital twin context. And this really becomes this natural platform because we have digital twin endpoints that we are building that brings collaborative services from many collaborators building those twins. And then we are putting these visual interfaces on top of them. This shows one of them, for instance, on top of that, you can put a presentation engine on top of an endpoint that brings and you can bring any data from NDP to that endpoint. So it enables really versatile modes of applications that we ourselves use. Last thing I want to talk about is the shells, because this become really interesting for many type of collaborators. We have, I think, about 6-7 NDP shells being actively built right now. And these are shells over the overall platform with additional functionality. So you can actually bring your content management system or other types of websites with many different functionalities and use NDP catalogs, login. Like when you log into Wildfire Commons in this particular one, for instance, you're logging it through an NDP standard authentication access control key cloak service. And in this case, we have members, pathfinders, different types of projects that are very much like the Wildfire Commons focus. And the rest of the NDP infrastructure becomes a backend to what we call the Fireforge. So expert network tool, community marketplace, those are different tools. But the Fireforge enables this community with a branded shell under the Commons that is built on top of NDP, on those central catalogs, and it enables some private cataloging and things like that too on top of that. For instance, what we use it for is, this is one application, Points to Panel, that brings some AI-generated metrics on LiDAR datasets. You're looking at a LiDAR scene, and these metrics and this whole scene is generated from ingestion of LiDAR data. So what we do in one of these workflows is Letitia in our team processes these LiDAR scans and creates visual representations of those scans in ways that integrate those metrics also into the catalogs. Letitia creates a workspace, and there we have like a community of 10 actually working on this together. Prepares the data, adds processing scripts from one of our other team members, and starts adding group members with collaborators and launch them into Workspace. And then that gets saved on OSDF. So it then shows up on the, it could be cataloged on NDP, but it doesn't have to be. It also shows up on then our Points to Panel interface. So this shows a little bit of within the shell. It's NDP functionality, but still it's a different environment as a shell. How Letitia then creates in her, she can create curated catalogs, but there's also curated catalogs that she can emphasize in NDP. And she sort of starts working with the data sets that she's interested in, and she creates a catalog and prepares her data. First of all, she can also upload data into the catalog or create a private data in her new curated catalog. So, and then she creates her workspace. I'm gonna quickly go over this. The workspace, she can add data sets and Git repositories that she received. And then she can then create a collaborative studio project and starts adding team members to it. And then after that, she's going to create a group. She's going to add some team members to it. And she adds that workspace she did with the Git and data sets that she was interested in. That now becomes available to her team in a reproducible way under that workspace. So when the team comes back to that workspace and opens that collaborative project and opens that workspace, they can launch that as a project on the National Research Platform, NSF National Research Platform, which is a Kubernetes-based environment. And that workspace opens there. And if the data sets, and in our case they are OSDF enabled, they get fetched when Letitia starts computing on it. And then she can run her code. She can clone her repository, run her code. And at the end, she's gonna come up with, it's a typical execution of what she's doing with the data. She's going to come up with that one image that needs to be available, the Points to Panel. And this is a bulk version. Like we have many of these. Of course, we are showing one image here. And then she can save those outputs on OSDF into the NDP namespace that for Burn for 3D in this case, or Points to Panel. And that makes it available to Points to Panel as an application that can pull from this. And of course, she could have chosen to also catalog this on NDP to make it available to others for the next set of analysis, but this is sort of the end of hers. So this is where I'd like to stop, but I hope we can work together. Manisha and I are here to answer your questions. Brian and I are very much connected on a weekly basis almost in these things. So I hope we can find a path to work with CICI projects and help your data management and other types of NDP-like capabilities. And I want to make sure it's understood NDP is under fast change.
Great. Oh, thanks so much. So I think the intent here was to give you guys, all the CC awardees some interesting opportunities, certainly for the CICI projects. If you are generating data, we really do. It's very important. We see the data, made made widely available via the kind of platforms available here. So would love to kind of encourage that sort of collaboration. If you're, and I think almost all of you are using data, whether it's in classes, in other research projects. So hopefully this is a very good resource. Uh, we have time for a little bit of questions if you want to have some questions here. We've also set up these sort of smaller group follow-ups, right? So two things we want to do with the smaller group follow-ups. So we're grouping you guys into sets of about 5 projects, and so we'll with each of those, that'll give you an opportunity to present your project, whether you're doing OSDF or NDP or you're not really relevant to data, I think it's still worthwhile to kind of see what that other set of projects are. You'll get a chance to present your quad chart in a little bit more detail. Certainly more detail than I did going over I think 20 of them in under 10 minutes. So we want to do that, and it also gives an opportunity to interact directly with these teams to say like, hey, this is really great, but I could use the following feature, or how does service XYZ work? As you can see, both those teams are, NDP, OSDF are, excited to kind of work with you guys and see what we can do. From perspective of NSF, Kevin and myself, right? We'd really love to see this, the broader community develop here, and we thought this is a great way to do it. I'll shut up, but let's see if we have any other questions from PIs. If not, we'll follow up on the subsequent meetings via the later schedule. Yeah. Questions, comments, concerns? What do you guys think?
So just one question about the NDP thing. During the talk, I was trying to play with it to understand the cataloging capabilities. Would you say so I looked for internet or networking relevant data and didn't see anything in the search that I did. Would you say the primary users of the catalog currently are more physical sciences or traditional sciences?
Let's Yes, I think there's a yes and NDP is a pilot project, and our initial case studies were in earthquake, wildfire, and food security. So you'll see those data sets heavily, but also over the last 2 years, there's been a lot of catalog additions in many other areas, but a lot of physical sciences indeed. It's not a subject focused platform, so we hope more data sets will be added. So whatever you choose to add in that sense, and it's for the usability and integration of that with related data sets in ways users would like to use it. The other thing I think that probably was lost in some of the translation of what we are presenting right now, there's no one-to-one match between OSDF and NDP. So I don't think there will ever be, maybe. But we are working on capabilities of adding like the OSDF namespaces through adding metadata and making them discoverable in NDP. And the capability is there in terms of once we find the data set to fetch it into a workspace and use the data in various platforms, with some limited examples at the moment. But there's no defined process. So there's a stewardship that's bidirectional, and it depends on stewardship of data on OSDF to be cataloged on NDP. But we are happy to work with any of you or anyone on using OSDF to ingest this.
Sure. I guess I was focusing on catalog because cataloging and discovery is a problem many of us share. And in the networking world, I know CADA has a large catalog. I'm at USC. We have a large catalog. Dartmouth just traditionally had a large catalog of wireless data. And I was trying to figure out if there's any commonality there or not. I guess we'll have to keep discussing that. So thanks.
Just one thing that Nanishi went off mute. One thing to add there is you could also bring your ontology and annotate data as well. So there's a way to integrate those various data sets into a catalog. So it sort of deserves conversation, sounds like.
Okay,
When
thanks.
you went off mute and I
was going to say what you said. I think it's growing, right? If there is a reason why we cannot upload a networking data set, we should see why not. But at least currently, the metadata that NDP needs is fairly high level. So it can point to that, and let's maybe have that conversation.
John, part of the challenge, definitely coming from the OSDF, is that the assumption is that the object store is autonomous in managing its namespace. And OSDF is, if you want, a routing service to this namespace. Now, if you have a metadata or a catalog about the namespace, the question is, how do we make it available and who maintains the integrity of this metadata? Because objects can come and go in the object store and are not visible to the OSDF layer. So it would be an extremely useful discussion to see how what you call the catalog, which is the metadata of your namespace, integrates into the OSDF that has a more global view of different object stores and namespace. That makes sense, what I said?
Sure. I mean, that's what I was trying to understand by playing around with the catalog.
Yeah, so how would you export, for example, to OSDF or to NDP the metadata that you have about your namespace, and how do you keep it current?
Right.
Because when you yeah, go ahead.
So we have a catalog of about 1,300 internet-related data sets, and I know CADA has several hundred others at least, and I know Dartmouth has several hundred. So, these are not Google-sized data sets, but they're more than just one-off. I can pointy-clicky my way through it. So there's a longer discussion to have here, I think.
I apologize for the train here, but John, let's have a discussion about how we bring not only your namespace, but the metadata in a way that is relatively up to date. When you update something in your data set, how does this information propagate? Because otherwise the users will lose trust in the catalog service, and then they will not use it. So that requires a use case that you can be a wonderful first step here.
Sounds good. We'll have to talk more.
Great.
Just to pile onto that briefly, right? And this is part of what we hope some of these meetings would help to spur is so from a broader meta perspective, right? Let me point out, so 3 challenges, but I think you guys all know, but so I'm just kind of preaching to the choir here a little bit. But so John raises an interesting point about what types of data are where. I can pick up just sort of off the top of my head, right? It would be interesting as we see AI tying together more and more data across different silos to unsilo the data. So for example, if there's great data there on fires and earthquakes, right, which might be something that we want an AI system to kind of analyze impact or outages, it'd be fantastic to tie that into IPv6 or IPv4 network data outages, right? And to sign up to be able to connect those together. Part of the challenge is there's a great, there might be a great place that both the researchers and or the AI know to look for wildfire data, and a different great place to look for, the network data. As a community, it'd be great if we can find a way to break those silos and bring it together. I think that's part of what's behind John's question. I'll even further than that, I'll say I have an actual example from from a different group that was less of a research but more of a smaller company. When I was at DoD, looking at some internet internet connectivity thing that stunningly did not know about a few resources, including three on the call here, right? With USCISI, with CADA and route views. This group was saying like, look, we're going to try to find a way to get internet routing data. So part of the problem is being able to find those things, making that more accessible to the community. If you're a I would suspect anybody in the networking community knows to look at and I'll just point to the PIs on this group, right? At John's work, at Kata's work, at the route views team and many others. But if you're brand new, or if you're coming from a different area, how are you getting to that? How easily is it to get to that data? The more we can solve that, and if some of these things lead to additional conversations, that's something we would love to solve from the NSF side. So, supplements, other potential things. So we can try to further entice that via resources as needed. So glad to have the discussion kicked off. I don't have the answers to any of those, but perhaps this group can get there. So, all right, thanks.
If we can improve any of your processes and help, multiply the impact of the projects, that's a big goal here as well, to bring in some collaborative pathways or make it available to other communities through NDP. So those are, I think, things that we could discuss further. And we have weekly office hours that we don't yet popularize so much. We are trying to also control our growth, but we would love to work with you.
So, John, from where we are coming, I wonder among the PIs, how concerned are they about the ability of the object store, the location where they keep the data, to become popular? We know that in our world it's easy to launch thousands of jobs, and all of them would like to read the same networking data that John has. And suddenly he has 1,000 or 10,000 requests knocking at his door. How concerned is he to become popular? Or others?
So at least for my data, I think we've seen reasonably broad use in the networking community, but our user community is on the order of hundreds of people. I'm not even sure the networking community is 10,000 people. So I'm not sure how many scientific communities scale to that level, but that's not my primary concern.
Yeah, but the question, you look at your consumer as an individual, but what happens if somebody is training 10,000 models and all of them want to use your data for the training because they want to look at different parameters in the model? So suddenly OSDF makes your data available to somebody who can launch 10,000 or 1,000. So the model changes. It's not the human that is fetching it, but they're sending out these thousands of requests, and they all want your data.
So you're certainly correct that we do computations that scale to tens of thousands or millions. I'm doing some of them right now. I think it's an interesting question of where do we want to slice the caching and storage question. And you guys posit one solution, and I think there's other ways to cut that. So that's a longer conversation, I think, at least for my data sets.
I would love to know where you are doing your computing now and see what maybe we can help you. And we don't view ourselves as a solution. We view ourselves as an option. We don't want to walk in and to say, this is the way, this is a way, and you decide what works best for you.
I mean, we could have a much longer conversation about that. Maybe I don't want to monopolize this conversation, though. Maybe we should see if other scientists want to weigh in, because.
So maybe one point I wanted to piggyback off what Dan said. I think part of what NDP is trying to do is to allow data sets to be used collectively, right? For example, in the Crescent project that we work with, which is for early earthquake warning, access to networking data would be critical, right? And in the delivery of their, both in terms of their computation, but also in terms of the delivery. And so being able to leverage across that, right, is important. And I think that is another case why adding some of your data sets and making them accessible definitely to the communities that are using it, but to broader communities becomes important, because it just opens up what you can do and what you can think of.
So I agree, and I'd love to work with you on that. Let's swap some email and try to talk about that out of band, because I'm not sure we should take 50 people's time on that.
Yeah.
Absolutely. And I meant it broadly for all data sets, not just this, right? All types of, but yeah, definitely. I'd love to have a conversation with you, John.
And some of this is the intent of the smaller breakout group meetings as well, to kind of discuss this in more detail. Any other sort of other meta comments or other directions? Well, nothing heard. We can, we'll continue the discussions. We're excited to kind of get the groups together. Thank you, everybody, for your time and your attention on this one. I think Kevin and myself and NSF, we're optimistic. There's something pretty tangible here, and once again, congratulations to all the new CC awardees. We're excited to have you guys on board, and look forward to moving forward on this. So thanks very much. The team will send out links to the slides, and there'll be a recording of this as well. So if you want to go back and replay something, you're certainly welcome to do so. Thanks very much.